Welcome. Let's take a look at using the technique of integration through substitution on a couple of examples involving exponential functions. Our first example is the indefinite integral of 2 times e to the 7x dx. And when we're trying to use integration by substitution, we're always looking for occurrences of composition of functions. So what I notice when I look at this integral is that the integrand has 7x as the exponent for the exponential function. The basic exponential function is simply e to the x, but in this case we have e to the 7x. And we also have this coefficient of 2. So let's go ahead and bring that 2 out in front of the integral sign. So 2 times the integral of e to the 7x dx. And then let's let u represent the argument in this composition, or this 7x. So we're going to let u equal 7x. Then du is u prime of x dx, and in this case u prime is 7. So du is 7 dx. Now, as I look at this example, we don't have a factor of 7 with which to create du. However, we can create that factor of 7 by simply multiplying by 1/7 and 7. So 1/7 times 7 is 1, and if I do that, then I can take and rewrite this integral. We'll multiply the 2 and the 1/7. So we'll have 2/7 the integral of e to the 7x times 7 dx. Simply reversing the order of the multiplication by 7 and the exponential function. At this point, I do have a differential du, and I can rewrite my integrand here, my exponential function, as e to the u. So I've transformed this original integral into 2/7 times the integral of e to the u du. Now the antiderivative of e to the u is simply e to the u. Recall that the derivative of the exponential function e to the x is e to the x. So if I'm going to do the antiderivative, if I integrate e to the x, I end up with e to the x. Then we'll have plus our constant of integration. Now we're not quite done. Our original integral was in terms of the variable u. Our answer here is in terms of the variable, our original integral was in terms of the variable x. Our answer here is in terms of the variable u. So we need to take this and rewrite it in terms of x. So we simply just need to replace u with what it was defined to be. And in this case, it was 7x. So our answer, to our indefinite integral is 2/7 e to the 7x plus c. Let's take a look at our second example here. I notice that I have a product. I've got -3 times x times this exponential. I notice that the exponent in my exponential is not simply x. So there is a composition of functions occurring here, where negative 2x squared is composed with the function e to the x. So let's go ahead and explore using negative 2x squared to do a substitution. So let's let u, our new variable, equal negative 2x squared. And if we do that, then du, or our differential for our new variable, our new integral, is u prime of x dx. And in this case, that would be negative 4x dx. So now I take a look at what my integral looks like. I've got this negative 3, and that's not really going to help me with this negative 4x dx. So that's just a constant. We'll go ahead and bring it in front of the integral. I've got an x and a dx. So x dx, that looks promising. I am missing this negative 4. So what we can do is multiply by 1 over negative 4 and negative 4. And use that to create our du. So what does this look like? Well, let's first bring the negative 3 in front of the integral. Let's do 1 over negative 4 times negative 4. And we all know that that's equal to 1. I'm going to write my exponential next using the commutative property of multiplication. So that would be e to the negative 2x squared. Then I'm going to write that x that I have, and then my dx. And so at this point, I can rearrange this just a little bit more, and I can now have the negative 4x dx that I need for my differential du. Also, let's go ahead and bring this negative 1/4 out of the integral sign and multiply that by the negative 3. So we get positive 3/4 antiderivative of e to the negative 2x squared times negative 4x dx. And now we're ready to transform our integral from involving a variable of x to a variable of u. So this negative 4x dx, that becomes my differential du. And this e to the negative 2x squared, that becomes e to the u. So what we have at this point is 3/4 the integral of e to the u du, and the antiderivative of e to the u du is 3/4 e to the u plus c. Now we're almost done. Remember that we do have to replace the u with what it was defined as to finish out the process. So the antiderivative here would be 3/4 e to the negative 2x squared plus c. And that's the antiderivative of our original function. I hope you find this helpful.